Hey guys, welcome back. Let me start this lesson with a question. Forget about Hadoop for a second. When you think of analyzing data, what immediately comes to your mind? For most of us, a database table would come to mind, right? It's not a surprise because we are so used to visualize the data in a table structure, in a row columnar fashion. And almost all of us are familiar with SQL. Data in Hadoop cluster is presented as files, and so far, MapReduce using a programming language or pig doesn't allow us to view the data in a table structure. So it is only logical to have a tool in the Hadoop ecosystem to represent the data sets in table structure and run SQL queries against it. Hive does exactly that. Hive was developed by Facebook and it is now a top-level Apache project. Just like Pig, it is also widely used in the industry. With Hive, you can create table structures for your dataset and then write SQL-like queries to analyze your dataset. That's every data analyst's dream, right? So Hive takes in a SQL query and converts the query into one or more MapReduce jobs and submit into the Hadoop cluster. So the question is, why do we need to have two tools, Pig and Hive, doing somewhat similar things? Pig takes in Pig instructions and convert into MapReduce. Hive take in SQL-like Hive queries and convert them into MapReduce, right? They're doing somewhat similar things. Pig and Hive were developed by Yahoo and Facebook respectively to solve the same problem around the same time. The capabilities of either tool was not fully transparent to both companies at the early stages of development, which resulted in the overlap. So the next question you might ask is, do companies use both Hive and Pig in the same cluster? The answer is yes. We have seen successful Hadoop implementation using both Pig and Hive in the same environment. Here is one such use case. You can use Pig for standard nightly ETL kind of jobs like extracting data, transforming and loading the data, and doing some predefined aggregations. You can do that with Pig. And Hive can be used by developers, data analysts, and scientists on a day-to-day basis for ad hoc analysis of data. In this lesson, we're going to solve the same problem, that is finding the maximum closing price by stock symbol, but this time using Hive. And you'll see how easy and fun it is. This lesson doesn't mean to be a detailed overview of Hive, but will serve as a very good introduction to Hive. The scripts for this lesson is in this directory in our cluster, hirw-starterkit /hive/stocks. You'll see a script with name maxcloseprice.q. So let's open the maxcloseprice file. So here's the script, right? So these are Hive queries. To work with Hive, you need to enter into Hive's shell. So let's type in Hive to get to the Hive shell. So now we are in Hive and we can execute Hive queries right in this prompt. The first step is to create a table in Hive. So let's go back to the other window. Here's the syntax for creating the table. If you have worked with any databases like MySQL or SQL Server, Oracle, etc., this syntax will be very familiar to you. You're creating a table with the name stocks_starterkit and you're specifying the list of columns along with its data type. Also, you can see the data types you're seeing here for the Hive table looks very similar to the data types from Java. Our stocks dataset is a comma delimited dataset. So this line here indicates the column in the dataset is separated by comma. Row format delimited fields terminated by comma, which means this table is looking at a dataset which is comma delimited. The location attribute points to the location of the dataset in HDFS. So the dataset is in this location, user hirw input stocks. So let's execute this script to create the table. Go back to our Hive prompt. Copy the script. There you go. The table is now created. Now we have created a table. Just like any table in a database, you can run SQL queries against this table. So let's try a simple select statement to bring in 100 records from this table. This table has a lot of records, so I don't want to print all the records on the screen. I just wanted to bring 100 records from this table. There you go. As a row columnar structure, you're seeing the result set. This is perfect, right? This is not all the records in the dataset. This is just 100 records from the dataset. Now let's say someone else created this table and you want to get more information about this table. like the column information and the location of the dataset, etc., you can use the describe formatted command to know more information about this table. So you're saying describe formatted and you're giving the table name. So let's try this command. As you can see, the first set of information from the describe formatted gives you the column names, the data type, etc. And it's also telling you who created the database, like who is the owner, and the location of the dataset. That is, this table is pointing to a dataset in this location right here. And the next important property is the table type, which in this case is external table. So if you go back to our create table script, you can see we have created the table as external table. What does it mean? There are two types of table in Hive, manage table and external table. With manage table, when you drop the table, the data in this location will be dropped or deleted. So you need to be very careful with manage tables. With external table, however, Hive does not delete the dataset when you drop the table. This is a preferred table type because since the same dataset can be shared by multiple applications like MapReduce, PicScripts, and Hive, you don't want to run into the risk of deleting the dataset accidentally by dropping the Hive table. So for that exact reason, we have made our table as an external table. You may also notice that we are using the same dataset in the same HDFS location for MapReduce program, Pig, and now Hive. So making the table external eliminates the risk of accidentally deleting the shared dataset when dropping this Hive table. Now we have the table ready and we can select the records from the table. It is now time to calculate the maximum closing price. So take a look at this query. It is a very simple SQL query. You're saying select symbol max close price from stocks_starterkit, which is our Hive table, and group the records by symbol. So this query is going to give you the exact output that we got from the MapReduce program and also from the Pig script. So let's try this query. So now Hive is taking this query, it is translating this query into a set of MapReduce jobs, and it's executing the MapReduce job into the cluster, just like what Pig did with Pig instructions. And you can also track this application by going into this URL. Here's the result set, the same exact result set that we got from a MapReduce program and from the Pig script, and the same exact result set. Just like you did with a MapReduce program or a Pig script, you can monitor the application with this URL. So let's copy this URL. There you go. Our Hive query is translated into this MapReduce job right here. As you can also see, the job name is populated by Hive, which is like select symbol max close price ... right? The state of the job is succeeded. So that is it. Beautiful, isn't it? Again, we just scratched the tip of the surface here for Hive. Hive provides a lot of interesting way to store your data with partitions, buckets, and also support powerful and more intelligent way of joining datasets. But I hope this lesson gave you a good introduction to Hive. With that, let's wrap this lesson.